Alright, so hypothesis testing for a small sample binomial. Let's say a large apartment complex claims that there are equal number of boys and girls. Okay, and this one guy, he suspects this claim and he carries out a test. All right, so he takes a sample of 10 children, right, and he observes that there are 6 boys out of those 10 children. So he sees that there are 6 boys. Okay, so now he wants to test the claim at a 5% significance level. So my significance level is 5%. Alright, now step 1 is the same. You declare your null and alternate hypothesis. So I say that my null hypothesis is that the probability of a boy is still 0.5, and my my alternative hypothesis will be probability is greater than 0.5, because the guy claims that the guy's claim is that there are more boys than girls, so the probability of finding a boy is greater than 0.5. So yeah, next you set up your sample binomial, that is x follows a binomial with n equals to 10 and your probability of success 0.5. Now to carry out the test, all you need to do is calculate the probability of the observed or more extreme values. So in this case your observed value is 6, because he observed 6 boys in his sample of 10 children. So you to carry out the test you need to calculate the probability of observed or more extreme values. In this case will be probability of x greater than equals to 6. This means probability of 6, 7, 8, 9 and 10. Right, you calculate these probabilities and this turns out to be 0.37. Now you compare your calculated probability to the significance level. If the calculated probability, that is your probability calculated, is more than your significance level, in that case you accept null hypothesis. If your calculated probability is less than your significance level, you reject null hypothesis. In this case our calculated probability is 0.37, right, while our significance level is 5%, 0.05. So since our calculated probability is greater than 0.05, we accept our null hypothesis. That is, we say that there isn't enough evidence to conclude that the probability of finding a boy is greater than 0.5, that the number of boys and girls is equal. So this is one way of calculating So this is one way to carry out the test. The other way is to find a critical region. So sorry, let me just fix this. So yeah, we said that X follows a binomial with n 10 and p 0.5, right? And this is what a binomial looks like, right? Discrete random bar. So 5, 6, 8, 9, 10. And the 11th bar. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So my alternative hypothesis was p greater than 0.5. So I know that my critical region lies on the right hand side. If it was p less than 0.5, I would have said that my critical region lies on the left hand side. But since it lies on the right hand side, since it's greater than 0.5, I know that it lies on the right hand side. So how to figure out your critical region? So to figure out your critical region, you'll have to calculate probabilities. Probabilities of what? Probabilities of the bar starting from the right hand side, that is from 10. Now you will calculate the probabilities of each integer of each bar and you'll add them up, and you will go all the way till the sum reaches is as close to 5%, such that when I add the next bar it tips me over 5%. Now in this case, probability of x equals to 10, this will turn out to be 0.000977. Probability of x equals to 9, this turns out to be 0.00976. Probability of x equals to 8 turns out to be 0.0439. Alright, so if I take the sum of these two probabilities, this is 0.0107. So let's see if I can get as close to 5% without tipping over. So I'll add the 8th probability as well, and this sum turns out to be 0.0546. So I am above my significance level, that is 5%. The significance level is 0.05, and right now I am at 0.0546. So this means that x equals to 8 will not be part of my critical region. My critical region will be 9 and 10, because the sum of the probabilities of 9 and 10 is 0.0107, and as soon as I add the probability of the 8th bar, it tips me over 5%, and to find the critical region you need to get as close to a significance level such that when you add the next bar it tips you over your stated significance level. So my critical region will be bar 9 and 10. So basically your critical region is x greater than equals to 9. So Now that I've found my critical region, all I need to do is place my observed value. If my observed value is in the critical region, I will reject H0. If it's not in the critical region, I will accept H0. So my observed value in this case was 6 because the guy found 6 boys out of a sample of 10 children. So 6 is over here, and since 6 is in the acceptance region, we say that we accept H0. Alright, so our stated significance level was 5%. That was given to us in the question. But we calculated our actual significance level. That is 0.0107. So 0.0107 is my actual significance level. The stated significance level was 5%, but once I calculated the probabilities of the bars, I found out that my actual significance level is 0.0107. So where else will I use my stated significance level? So if I have to find the probability of type 1 error, this will become simply my actual significance level. So when we were carrying out tests using normal distribution, the probability of type 1 error was the significance level that was given to us. But in a small sample binomial, the probability of a type 1 error is your actual significance level that you calculate yourself to find the critical region. So this was type 1 error. So for type 2 error, it's basically your acceptance region with the new P, with the new probability. So let's say the question says that find the probability of type 2 error, given that the probability is in fact, let's say 0.55, just a random example. So your probability of type 2 error will be probability of x less than equals to 8. That is the entire acceptance region from 0 to 8. But your P will be 0.55. So this was probability of type 2 error. Type 1 error is your actual significance level. Type 2 is your acceptance region with the new mean. And this is all for small sample binomial and both of its errors.